Hi folks. Today we're going to look at using a really cool app called RemoteXY along with a really cool chip called, or module I should say, called I'll hold it over here, the ESP8266, and it's going to let you drive your robot around and fire that cannon with your phone. So you'll have forwards, backwards, right, left, and fire. Where's that fire button? Driving and firing. Ooh. And we're also going to be able to monitor the battery voltage, which you can see dropped really low when I was driving and firing the cannon at the same time. How do we do it all? That's what this is all about. So the magic of driving your Boombot using your phone comes from this little module that plugs in right here on the back corner. And you can see that it's purposely exposed right here. Most of the chip's covered up by your shield, but this is exposed at the back. And that's because, let me get that in there so you can see it, these little wires, that little section of trace on the circuit board actually forms an antenna. And it's an antenna for the ESP8266 chip. There we go. Bring that into focus right there. Now this is a neat little module. And this one even has its pinout written on the back of it, which can be handy sometimes. And anyway, so what this does is for a few bucks, it allows you to use your Arduino's serial data interface to communicate over Wi-Fi to the internet. Now, we're not going to go full on and go over the internet. We're just going to use this to create a hotspot so that your phone can talk to the hotspot. And we're going to use some really neat software called RemoteXY to send commands from a cool graphical interface that you'll develop for your phone. And you'll be able to get this all integrated together. But I just wanted to take a moment and talk about this ESP8266 chip because it's actually around in a lot of things, light switches, uh, basically home. Any Internet of Thing device or that you've got for your home has a chip something like this in this. I've actually opened up some I guess they're Wi-Fi controlled switches to turn 120 volts on and off to appliances and things like that. And I've actually found an ESP8266 module just like this one soldered right in there. So it's pretty cool. Now, in addition to plugging in right here, I've also left room right here on the back of the board to plug a Bluetooth module in right here. So there's some Bluetooth modules that can plug in right there. And that was what I was originally using to drive the robots around with. They'll also work fine with RemoteXY, but I stopped using them because Apple phones at the time, I don't know if they do now, didn't support the Bluetooth serial stack. So some of the apps that were supposed to work with them didn't work well. But anyways, if you want Bluetooth, there's Bluetooth modules that will drop in right here. And if you want Wi-Fi, which is what I'm going to be talking about, you plug your ESP8266 in right there. There's all sorts of other things that you can do with an ESP8266 once you start playing around with them. You can plug them into a breadboard on your computer. Now, if I've got to plug them into a breadboard, what I'll do so that I can fit these pins in here nicely is I'll take two stacking header strips, kind of like so, and just bend them out a little bit so that you can then plug that in down the center aisle of your breadboard. That gives you the spacing that you need to get over top of that gap in the middle of the breadboard. And then you can hook this up and you can actually reprogram this chip. You can download the add-ons for your Arduino IDE. So right in the Arduino integrated development environment, you can write Arduino style code and you can program it onto one of these chips. And that's really cool because you can get these various different modules. This is a temperature and humidity module right here. And you can take an ESP8266 and plug it into one of these modules right here. And if you've programmed your ESP8266 properly, this can connect to the internet over Wi-Fi and upload the temperature and humidity from this sensor, so long as you give it a source of power. and it's even got a couple of pins right here, so adding the source of power is pretty easy. So there's pre-made modules that work beautifully with the ESP8266. Here's one that allows you to connect it to USB. And when I pop that right on there, I think it went that way around. Now I can use these little buttons down here to set it into programming mode, and I can actually upload code directly from the Arduino onto that ESP8266, and it can run code independently. You don't need an Arduino to make it happen. Now, everything that I'm going to show you is still going to be based around using your Arduino to control that. But here's an example of something that I'm doing with an ESP8266. This is an ESP8266, a little module, not unlike this one, with the ESP plugged right into it, hooked up to a power supply, and stuffed into my, well, we'll say my auxiliary beverage fridge in the basement, because it's critical for me to be able to tell from anywhere on the planet what's going on in my beverage fridge. And so we've got the temperature and humidity on here, and this is using an app and web service called Blink, B-L-Y-N-K. It has a beautiful app for generating these lovely interfaces and great tutorials showing you how to get hooked up for connecting your, well, pretty much anything you want over the internet. And right now I'm using it for data logging, but I've got other apps that I've set up. In fact, I've did a contracting project a while back where we used it to control an entire prototype power station. It was pretty cool. So in here, you've got all sorts of different things that you can add right now. Ooh, my relative humidity just went up to 13 right there. So let's see on this chart, what are we looking at right here? There, my relative humidity is showing in blue along the bottom, and you can actually see a spike in here. I'm on the 12-hour scale right now, and there's a little spike in here where the fridge went through a defrost cycle, and I think somebody just went downstairs and opened the fridge because you can see the temperature going up a little bit. And it logs your data. I just rebooted it right in here, but actually I have data from the past month stored on the web or on the cloud, I guess is a better way of describing it, keeping track of all that information. And you can get it right down to 15-minute intervals of what's going on. Anyway, that's Blink. It's not what we're doing here, but I am doing it with an ESP8266 chip. So we're going to take a look at using the ESP8266 to do one thing with RemoteXY, and it's going to be cool. But the potential to do things with an ESP8266 is quite a bit greater. And that's why I've got over here, I've just brought up the Wikipedia page for the ESP8266, and it talks a little bit more about it now. The ESP8266 has been around for a while. It is being replaced by more modern, faster, bigger processors, the ESP32, but we're using this version called the ESP8266-01, and that's a really standard thing because it's been around quite a while. You can find tutorials out there, examples, all sorts of neat things. Just type ESP8266 and Arduino, and it will help you out on it. Okay, and this Wikipedia page goes into a lot more detail. You'll also see this name AI Thinker come up. That's the name of one of the companies that sort of popularized this chip maybe 5 or 6 years ago. And it's used in a whole bunch of other boards in here. Anyway, that Wikipedia has that information. And as I mentioned, Blink is what I'm using to do my data logging. And it has some great tutorials and examples of how you can not only monitor things remotely, but control them as well. And we're definitely going to use RemoteXY to create an app for this device, and we're going to manage it. So that's cool. So somewhere you should have an ESP8266, and you can put it into this box right here on, make sure both the pins go in there. All 8 pins go into all 8 holes really nicely. Let's take a look at the schematic and see some of the things that are going on and how your Arduino talks to this. Because when we're taking a look at the schematic, you'll be able to see why some of the things we've done are important. So here's the schematic, and I've zoomed in on a section of it down at the bottom right here. You can find the full version of the schematic in well, at the beginning of the electronic assembly reference guide, but I can give it to you in Design Spark format as well. And this is your ESP8266 module down here. Now, a couple of things that you need to know about the ESP8266 is that it likes to run at 3.3 volts. Our Arduino is a little bit of an older microcontroller, and you'll see that a lot of new microcontrollers and microcontroller devices run at 3.3 volts instead of at 5 volts. And that just allows them to use power more efficiently. Okay, they're building the chips more efficiently, so they don't need as much voltage, they don't need as much power. They run cooler, the batteries last longer. It's all a good thing for the environment. Now, our Arduino does run at 5 volts. And if you try to run a 3.3 volt device at 5 volts, well, that's kind of like running a 5 volt device at 9 volts. You might get lucky, but it'll probably burn out. So what we wanted to do is we wanted to have a 3.3 volt power supply for the uh, for the ESP. Now you will see on your Arduino right up here, if you look on your Arduino, that there is a 3.3 volt regulator built onto the board and a 3.3 volt output on the Arduino, which you'd think would be ideal for something like this. And it almost is. The catch is Wi-Fi data transmission isn't a continuous steady state of data. It is do nothing, do nothing, do nothing, do nothing, wham, and send a packet of data. Do nothing, do nothing, do nothing, wham, get a packet of data and process it all. Okay, but it's particularly that sending the packet of data that takes energy because the chip instantly needs to create um, uh, a radio frequency in the antenna right here. So it needs some power pretty quick. And anyway, what happens is if you try to run it off that 3.3 volt output from your Arduino, you can't get quite enough power to make it work reliably, quite enough current to be specific to make it work reliably. So we need a better power source. And so what we do is we actually hook it up to our 5 volt line. This is our 5 volt right here. But you'll see that I've got two basically useless diodes in here. Okay, the diodes are doing nothing for their normal role of blocking current from flowing back in that direction. There's no way that current's going to flow back in this direction. What we're using them for is the fact that when they're drawing current, there's a forward voltage drop across the diodes. These diodes being silicon, somewhere around 0.6 or 0.7 volts. So if we say, well, this is a 0.6 volt drop, that brings our voltage from 5 down to 4.4. And if this is a 0.6 volt drop, that brings us down to 3.8 volts, which is close enough that the 3.3 volt chip on the ESP8266 isn't going to go up in a cloud of smoke. So we actually use these two diodes as a cheap and gimmicky voltage regulator. Okay, now it's not going to work if they're not really a regulator, because if you put 6 volts up here, you're only going to get a 2 volt drop coming down here. So you want to make sure you've got this being a good regulated 5 volt supply. But if you've got that, then this one's going to come out at less than 4 volts, and your ESP8266 is going to work just fine. So you'll find those two diodes on your board. They're right down in this corner here, kind of tucked right in there. And that's what they're doing. They're just dropping the voltage a little bit so you don't blow up your Arduino. So you don't blow up your Wi-Fi module. And because the Wi-Fi module requires a sudden surge of current, what we've done is we've put a capacitor right here to help hold this pin at a steady voltage. So when it needs that blast of current, there's not a huge capacitor, but just a little bit of capacitance to make sure that when it draws on that, there is something to absorb that. It doesn't all have to flow through the diodes to keep that powered up. Okay, now, so we've got our power supply, our 3.3 volts, and our ground right here. Okay, now there's some pins that we don't use on here, and these are actually GPIO. If you ever see GPIO, that stands for General Purpose Input Output, and that means those are chips that if you write your own code for the ESP8266, you can make them do useful things, and that's part of how I'm communicating with the temperature and humidity sensor in my beverage fridge. There's also a reset button right here, which you can help use to kick it into program mode and reset the chip. So that takes care of those ones that we're not using. The main ones that we're interested in right here are the TX and the RX, because we're going to use the serial data protocol to get data to and from our Arduino. And so our RX pin right here, you can see comes right up here, goes past that Bluetooth module. There's the where the RX pin would be on there. And it comes in right here. And pin 0 on the Arduino is the RX pin. That's where RX is short for receive. And that means that data, when you send data from your computer, when you do um, when you program the Arduino, the data comes in right here. And when you transmit data from the Arduino, when you do a serial print command, that data comes out pin 1 is a series of pulses. And normally it flows back to your computer. But in this case, this wire takes it down here, and if you've got a Bluetooth module in, it'll come down in right here, and it'll go into the receive pin on there. This one comes down here, and this is actually marked as the receive pin on the ESP8266, because when you're doing serial, you'll have a transmit pin over here going pulse, 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 sending data down the lines to a receive pin right here that's listening for that data and then goes and processes it right away in here. So these two pins are talking back and forth to get what you want from your Arduino out to the Wi-Fi and what you want from Wi-Fi to come back into your Arduino. So there's fairly sophisticated communication taking place over these two lines. Now, that's all well and good, except for the fact that these two lines are also used for reprogramming your Arduino and for your communications with the computer. This presents a problem because when you try to send data from the computer down this line and it comes to the receive pin, okay, the ESP8266 might also be transmitting data to that receive pin. And now your receive pin is going to be listening to the outputs from two different devices. And as you know, if you've tried listening to two different devices talking at the same time, that's really hard to figure out what's going on. So what you'd have to do, and in my early setups and early versions of this board, in order to program the Arduino, you actually had to come in here and you had to remember to unplug the ESP8266 and pop that out of there. And then you'd upload your code and then you'd say, okay, I'm ready to test it. You'd unplug from the computer and you'd plug your ESP8266 back in, and then you'd reboot everything and you'd see if it worked. And that got to be really tedious with the unplugging, plugging, and normally it was worse than tedious because I'd usually forget to plug things back in or forget to unplug. And anyway, it worked, but it wasn't all that nice. And I thought, wouldn't it be nice if you could just turn the ESP8266 off automatically when you wanted to program your Arduino? Turns out the people who designed the ESP8266 had a similar thought a little bit before I thought that. And as I was reading the documentation, I realized that they have this pin called CHPD enable. Now, you probably remember that we've got enable pins on our L293D right over here, and that in order to activate this side of the chip, you had to make enable 1 go high, and in order to activate this side of the chip, you had to make enable 2 go high. So the concept of an enable pin, and basically a little digital on-off switch for a microcontroller or anything that interfaces with your microcontroller, is pretty common. And here we have CHPD enable. I have no idea what CHPD stands for. I know what enable means though. And so what we've got right here is I've got this pin on your board tied in through resistor R2 to ground. So unless you are actively sending it data, unless you're actively holding that pin high, it is going to be low. Okay, and when CHPD enable is low, this chip is going to be off. Okay, well, if you want to set it high, what we've got right here is we've got pin 8 on your Arduino. No particular reason it was pin 8 other than the fact that it was available, and I could route it on the board without too much of a mess. So pin 8 on your Arduino is something we're going to call CHPD enable. And when you set pin 8 high, it's going to come down here and it's going to illuminate this LED on the back corner of your Arduino, LED 3. And when LED 3 is glowing, that's going to have a voltage drop across the LED. And then that current's going to flow down to ground. But now this pin is going to see the 5 volts coming off pin 8 minus, and this is why in the instructions I recommend a red LED right here, because it'll be minus about 1.7 volts when that LED is lit up. So you'll get about 3.3 volts coming out at your CHPD enabled chip right here. And the rest of that current will just flow down to ground and your ESP8266 will turn on. So you now have a way in your Arduino code to turn on the ESP8266. And when you go to upload code to your Arduino, the Arduino receives a signal from the computer saying, hey, new code coming, and it turns all of its pins off. So when you go to reprogram your Arduino, you don't have to unplug the ESP8266 because the computer tells the Arduino, hey, I'm going to reprogram you now, set all of your pins off. Okay, and what it does is it turns them all to inputs basically, so they're really neither high nor low, but that's perfectly fine because this resistor sucks this pin down to 0 unless you've actively told pin 8 to go high. So basically, you can now upload code to your Arduino with the ESP8266 permanently attached in there. So when I talk about CHPD enable and when I talk about serial data going back and forth, that's what we're going to be doing on here. Some of the tutorials that you will see for using your ESP8266, we'll talk about using software serial. Because you've only got 2 hardware serial pins, pin 0 and pin 1, on an Arduino Uno. You have more serial ports on bigger chips, but I stuck to the Uno for this project. Because you've only got the one hardware port, people will, there is code, a library called the software serial library that allows you to use basically any 2 pins as a serial data and transmit port, because really all you're doing is turning pins on and off to send serial data. The catch is software serial requires a lot of processing to do. When you do it with hardware serial, it all happens really fast in the background because there's specific I'll say code, but specific transistor sections built on your chip to handle serial data. And you just say, okay, send this data, and you hand it off over here. And it's like having a coprocessor handle the transmit and receive for you. When you run software serial, you need to be doing a lot more processing, and your software serial cannot transmit and receive as fast as your hardware serial ports can. And that matters because the data rate that we're using to communicate with this is an important part of the communications. So just like you've got probably this video turned on to 200% speed right now, there's different speeds that your Arduino can talk to your ESP8266. The most common default setting that I've found for talking to the ESP8266 is 115,200 bits per second, okay, or 115K BPS. So 115,200, you'll see that in your Arduino IDE on the drop-down menu. That is faster than software serial can transmit. Well, it could probably transmit that fast. It just has a hard time receiving that fast. So it's faster than software serial can talk. So it was really important that we be able to use these hardware serial ports on here so that we can match the default data rate on the ESP8266. For students in my class, there is a section of code up on D2L, the Learning Hub, where if you're wanting to reset the data rate for an ESP8266 for any reason, you can go and download that code and it will go through here and it will reset the data rate to whatever you tell it to. And then it'll create a little Wi-Fi network so you can check and make sure that it worked. There's also amazing tutorials online that will show you how to hook this up to a breadboard and do all sorts of amazing things to the point where you'll probably want to get more ESP8266s, or you'll be sitting there saying, the 8266 is kind of obsolete. I want to play with the ESP32 or many of the other new and amazingly inexpensive Wi-Fi chips that are out there. There's really cool stuff going on with this. Anyway, let's take a look at RemoteXY and what we're going to do with that on your phone. Okay, now, now to get started with RemoteXY, what you're going to have to do is go to your phone's app store or your tablet's app store or whatever, but you are going to need an Android or iOS device to make this happen. And go onto your app store and search for RemoteXY. And this should be available for iOS and for Android. And you should see both the RemoteXY free right here and the paid version of RemoteXY. So start with the free version, but if you like it and you think the price is reasonable and you'd like to support the developer in coming up with cool tools like this, the Pro version does give you a couple of extra features. Okay, so you're going to go through and you're going to get that installed on your phone. A little later on, when you start exploring on there, you're going to see that there's a whole bunch of other things that are designed to work with your phone and an ESP8266 chip. So take a look at Blink and Arduino controller and Wi-Fi controller. There's all sorts of cool stuff for interfacing to an Arduino available. Now, I've already got the software installed, so you're going to go and install it. And when you're done, you should have a couple of apps on your phone that look something like this. I've got RemoteXY free and I've got RemoteXY right here. Now, when you start it up, you probably won't have all of these options available on it. Okay, these are some of the robots that I've had connected to it in the past, but RemoteXY should start up and it should run. And that's great. Um, that's all you need to do with your phone for right now. Now in your web browser, you can go to remotexy.com and you should see a page that comes up that looks like this. And you can work through the tutorials on here. They'll show you to do a whole bunch of cool things. And like I say, this can work with a whole bunch of different chips, and it's just awesome what the developer of this has done. So it's got examples in here and how to get started. And basically come in here and tell it you want to get started. Okay, now I've already been doing a few things on here, so I'm going to show you what I did to get the code that I've got. Okay, so you need to configure this, and over on this window right here, you should see one that says Properties, and I'm going to click on my configuration. And so there's a number of different ways that you can configure this. I'm going to configure it as a Wi-Fi access point, okay? But you could, if you wanted, configure it to go over the Ethernet, and you could connect your ESP8266 to your home network and connect your phone to your home network, and then you could connect the two together through that network so that you could be driving somewhere else. You could go through a cloud server if you wanted, and you could have your Boombot left at BCIT, and you could be using your phone from home, and theoretically you could be driving around in BCIT remotely from home. There's no reason that you can't do that aside from the security on BCIT's network. The ESP8266 is a pretty simple chip and it doesn't work that well with security. Anyway, the simplest way to set this up, and the way we're going to do it, is we're going to make your Boombot into a hotspot. So we're going to turn it into a Wi-Fi access point. Okay, so select that and just click Apply. Okay, now the next thing you're going to need to do is pick the device. And you can write code, and this is going to develop your code for you. It's really cool. It's like a friendly programming interface. It does about 20% of the work, 30, 50% of the work, whatever, it does some of the work for you. So you have to tell it what sort of device you're going to be using. And obviously we're going to be using an Arduino Uno, but you could use this to work with an ESP32 board, all sorts of different processors out there. We're going to use the Arduino Uno. Then up at the top, you can either go back to the menu. We're going to click on the ESP8266 Wi-Fi module because there's a bunch of other ways that you can connect. There's that Bluetooth module that I was talking about, the HC05 or 06. You could use that. That plugs into your Boombot board just fine. Okay, but we're going to use the ESP8266 Wi-Fi module, so that should be selected right here. And then it asks you how you would like to program it, and we're going to be using the Arduino IDE. You can actually use the MP Labs integrated development environment. And I don't know what FLprog is. Maybe it's better than Arduino. I don't know, but we're using the Arduino. So we'll get that all set up and we'll click apply. Now over on this side of your screen, you may have to, I think the property shows up in here, but you should see Wi-Fi, Arduino Uno, ESP8266, and Arduino IDE. Now, this section right here tells us how we're going to talk to the ESP8266. So you have to select hardware serial, okay, and it will automatically default to the only serial port that you have available from an Arduino Uno. If you were using a fancier microcontroller, you could choose which one you wanted to use. If you're using software serial, you'd also choose which pins you want to use. And finally, we'll pick our baud rate right here as part of our communication. And as I said, we're going to use the standard default for most of the ESP8266s of 115,200 bits per second. If that's not connecting, we do have ways of changing that using something called the AT commands. Just takes a little bit of farting around, and I do have some code that can help you out with that. Okay, now, what is the name of the access point? I'm going to just call mine Boombot for right now, but if your Boombot has a name or a unique identifier to it, so that when you're running your Boombot in the classroom, you can identify your network from everybody else's, probably a good idea to put that on there. So you might want to call it Boombot the Best or whatever, Jason's Boombot, or just call it Jason. Well, if your name happens to be Jason. It would be weird if there was like a whole bunch of networks named Jason. So let's take a look on here. You can do a few things with your interface here. You can play around with the background color on it. I'm just leaving it at black for right now. You can mess around. You can have a vertical interface on your phone. I'm leaving it horizontal. You can apply passwords. Right here you can see I've said I'm using an open access point. If you turn that off, then you'll have to type in a password to access the Wi-Fi. Okay, keep in mind you're forming a hotspot. So just as when you set up a home network and you have an SSID, which is the name of your network, you can also choose to have a password, no password, or make the password as complex as you like. Okay, alrighty. Now, all you've got to do is drag the things that you want onto the interface right here. Now, I've already dragged LED on here. Let me just delete that so I can show you how awesomely challenging it is to create a command on here. Drag the button on, click on the button, okay? And now somewhere on here, down there, when you scroll down there, you can see I want to change that around. I'm going to change it to yellow, doesn't show up so well. Maybe I'll set it to red, pick whatever color you want. And instead of caption on there, I'm going to say LED. And I'm just going to use the name button 1 for right now. You could call it, actually, I think in my code example, I'm going to show you, I call it button 2, but whatever. You could have this be LED button or button LED or whatever you want. You can make it round, you can make it rectangular. You can come back here and you can make it really, really big. You can make it really, really small. Okay, make it big enough so that your thumb can touch it. You can have the borders around it. Now, there are some, let me drag down all the way down here. There are some things like call it this snap to pin right here. We're not going to do that. You can read in the tutorials about what that does. It actually simplifies some of the programming stuff. It's pretty cool, but we're going to ignore that because we want to do a fairly custom interface for controlling our robot. So basically you get one button on there. We're going to come back and we're going to add joysticks. We're going to do a lot more things. There's the joystick, there's a slider. We can put some color in to control your NeoPixels later on. You've got multi-selects, you've got on-off switches, you've got all sorts of cool stuff. We can come in here and we can add indications to read things from our robot, so our robot can send data back up here and you can see on your phone what the voltage level is going to be. The sound one is a new one. I haven't played with that yet. That's pretty cool. The online graph I also haven't played with. There's some new things on here since I've used it last. And then you can add some decoration. It looks like they've got the ability to add multiple pages of screens on here. So this has been really fixed up in advance since the last time I used it. So it's one of the reasons why I'm happy about having paid for the pro version. Support your local programmer who's doing cool and geeky things, even if your local programmer happens to be in Russia in this case. Okay, really cool interface right here. Now, you've got it set up the way that you want. And you can save this project. There's all sorts of options up there. But the thing that we want is to get the source code. Okay, when you click on Get Source Code, the computer, the website, takes what you've put on that interface and it takes the parameters that you've entered and it takes what you've put on the screen and it generates an Arduino file that looks just like this. That you can highlight everything on there and you can copy and paste it into your Arduino IDE because you set everything up to work on the Arduino IDE. And when you do that, it should go ahead and it should compile just fine. Now, I've already got some code that I've put up on the Learning Hub for my students, okay? But if you're doing this for yourself, just go ahead and take that and copy and paste it, and whatever you put on that screen is going to show up there. In fact, what you entered on that screen is represented in this array right here. So as you get a more complex screen, that array is going to get bigger to represent more elements on the screen. And this is a really cool thing about this, is this code is going to be living on your Arduino. And when you hook your phone up to your Arduino, okay, your Arduino transmits the data through the ESP8266 to your phone, and it says, I want the screen to look like this. So your phone only needs the app. It doesn't need to know what the interface looks like because your Boombot will tell it. And when you connect to my Boombot, your screen's going to look different than when you connect to your Boombot, assuming we've developed different screens. Okay, that's what that's doing right there. Now, there's some other important parts of the code right in here. Obviously, the first part right here, you can see the comment command. So this is all commented out right in here. Okay, and it reminds you of this really important part right down here. Okay, your Arduino IDE needs to have the RemoteXY library installed on it. So just pull up your Arduino IDE and let's see on here, where did I have that hooked up? Okay, that showed up on the wrong screen, but we can get rid of that. There we go, this is on the right screen now. And this is the version of the code that I've put up on D2L, the Learning Hub for my BCIT students. I'll try to make it freely available somewhere else, but it's a little too big to just throw into the comment section for this video. Okay, and as I was saying, you need to come in here and you need to go to Manage Libraries, and your library management tool will pop up on here. And as for any of the external libraries that we add, type in RemoteXY, and it's a search out there, and for all your RemoteXY projects on there, and you need to go in and install that. Okay, mine should be showing that it's installed because I know it's in there, but you do need to install that. Alrighty, when you've got that installed, what that's going to do is it's going to be able to do the hashtag include and go out and get the code that Evgeny's written, and I think I pronounced that right, I hope, and have that available to you. And here are some of those settings that we set into the online web editor. Okay, so we told it that the RemoteXY mode was going to use an ESP8266 chip, and we were using the hard serial, and that we were going to be an access point. Okay, so we're forming an access point on our ESP8266, talking to it using the Arduino Uno's hard serial port pin 0 and 1, and it's an ESP8266 that we're talking to. Okay, and then it confirms some of these settings right down here as it defines some of the terms that the library is going to use. There's that baud rate that we set up. There's the network name that we set up. You could change it right in here to a different name. That wouldn't affect what was going on. Here's the password. Now just leave it as quote, quote, if you don't want a password and open network. But if you did want something a little bit more secure on there, you could type that in right now. You leave the RemoteXY server port alone. Uh, Much more advanced if you want to get into changing those things around. In this code, you're going to see the configuration set up for RemoteXY, and you're going to see this pragma command pop up. Now, pragma is a C language instruction to the compiler. This isn't just like any of the hashtags that you see at the beginning. This isn't part of your program code. This is saying, hey, compiler, I'm going to tell you how to create some variables in here, and this is how I want you to store them in memory. Okay, so it comes in here and it creates this array. You'll see the term uint8t used from time to time. I define this down here in the code a little bit. That is an unsigned integer, okay, of 8 bits in length, also very similar to the byte size variable in Arduino. Okay, so you're saying set aside for each of these pieces of information 8 bits of memory. Okay, um, and don't worry about whether they're positive and negative, they're all going to be positive. And so this is going to be the array that defines the screen and that RemoteXY will transmit up to your phone. Now, this one is also going to be important, okay? Struct means that you're building a structured variable, okay? And that's sort of like a super variable. We've got ints and floats and even strings and things like that, but a struct allows you to piece those together into a more complex, well, almost an object. Object is a special word in object-oriented programming, so I don't want to quite go there, but a structure is a way of building a super variable, a complex variable, and inside this variable, we're going to have 2 elements to the variable. One is going to be called button2. Okay, like I say, when I was playing around with my interface, I dragged a couple buttons on the screen. I was left with button 2. Yours might say button 1. It's not a big deal. But right in here, if button 2 or button 1 or whatever you call it is being pressed on the screen of your phone, then that's going to show up as 1 when your Arduino reads the data. And otherwise, it's going to show up as 0 when your Arduino reads the data. And there is also a connect flag that's going to be 1 if your phone is connected to the ESP8266 and to the Arduino, and otherwise it's going to read as 0. So all of this code so far has been generated by the website. You know, your code. You won't have all my comments in here because I went back and added them so that if you're reading the code, you can have some idea what's going on if you're looking at it for the first time. And this variable, this structure, the super variable that we've created is called RemoteXY. Now, to see inside that variable, I'll just show you right down here. You've seen this format before where you've had the name of something dot the other thing. Well, there's the name of your structure. The super variable is RemoteXY, and here's the element inside that you want to access, button2. So you're saying, return the value to me that is stored in the button2 element of the RemoteXY structure super variable. This is where that RemoteXY name comes in. You could change that to Bob, and anywhere else in the program where it said RemoteXY, change that to Bob, and it's going to work just fine. It's not going to make much sense, but yeah, the computer will make The computer will understand. It really doesn't care. It doesn't know the difference between Bob and RemoteXY. Sorry, Bob. Um, so Pragma in here, again, an instruction to the compiler to go back to its usual way of creating data structures, way deeper into programming than we can get in this course. And just rest assured that it's doing magical things talking to the compiler. And that's all the code that's generated automatically by the ESP8266. It'll also have a line down here that'll say RemoteXY in it, okay, or initialize RemoteXY chip. We add a little bit to it. Okay, I want to turn some LEDs on and off on my machine. Now I'll show you a little bit about what this is going to do right here. Let me just lift this up. I'll pause for a second and show you what it's going to do. Okay, here we go. I've got it up and running. You can see that I've got one LED on already. That's the connect because I've got this all configured on my phone right here. And now when I touch that LED button on the phone, which is harder to do doing it all in reverse over the camera, but when I touch it, the other LED comes on the Boombot board. So I'm using my headlights as indicators to show that it's all working. And I've got my connect LED on right here. I've got my button LED. And when I take my phone and I disconnect, let me just turn off RemoteXY and disconnect my phone from that wireless network. Go back to my home network. You'll see that I lose connection and my connection LED just went off on there as my phone stopped connecting. Okay, so how do we go about connecting to our Boombot when this is up and running? Okay, well, first of all, you're going to have to upload your code to the Boombot. Oh, we're going to have to make a couple changes to it first. Okay, let's take a look at the changes that I made. They're pretty quick and easy. In your setup routine, okay, because we're going to use pins 9 and 13, our left and right LEDs, you have to set those to be outputs. Okay, otherwise these two LEDs down here aren't going to work. So set them to be outputs. And pin mode 8, we also have to set to be an output. Now pin mode 8 is that CHPD enable that I was talking about right down here. This glowing red LED needs to be turned on in order for your ESP8266 to be enabled and working. I'm trying to see if I can stand this up so you can see that a little bit better, because we are going to turn that off when it comes time to reprogram. There we go. Maybe that'll just stay there by itself. Okay, then we're going to do a digital write to pin 8, which is the first thing that our Arduino is going to do when it starts up, is it's going to turn on the ESP8266 chip. It's going to wait 100 milliseconds. That's a long time for a microcontroller, but just give it a chance to wake up. And then we're going to use the RemoteXY library to execute the RemoteXY initialization command, and that's going to tell the ESP8266 all the information it needs to know, establish the Wi-Fi network, and have the information ready to go for the phone when it connects and says, hey, what's the interface going to be? Now, this is a really important command down here in void loop, because we want our data to update regularly from the phone. The only time that updates is when you run the RemoteXY handler routine. Okay, the RemoteXY handler handles all of the communication between your phone and that chip. So if you don't call RemoteXY handler, you don't send data to your phone and you don't get data from your phone. So that's got to keep running fairly frequently if you want to have a snappy interface to your phone. Now, every time you do that, you're going to get new values into the RemoteXY structure, okay, or Bob if you called it Bob. And so what we're going to do is we're going to do a digital write to pin 13. And the value we're going to put in there is either going to be high or low, 0 or 1. And so we're going to look inside the RemoteXY structure and we're going to extract the value for button 2. Okay, and so if the screen is pressed, on button 2, then we're going to digital write 13 comma high. And if it's not pressed, we're going to write digital uh, write 13 comma 0 low. So we're going to turn this LED on and off over here. And if we want to check our connection status, we're going to come in and we're going to look inside the connection right there. And we're going to say, oh, connect flag. Is it 1? Does that mean we're connected? Or 0 means that we're not connected? Okay, that's all the code that we've got in here because we're just turning an LED on and off. We have come up with yet a more complex way to do a winky blink, basically. And so here we go. It's a connect flag on here, and that's what's running on your phone. You run that and you upload that to your Arduino. Now, notice the cool thing. Remember I said that in the past we had to unplug your Arduino? Watch what happens to the CHPD enable chip when I hit upload. Well, okay, the first time it doesn't turn off. Here we go. We go to upload, and you should see CHPD enable turn off. And now your code goes up to the Arduino. When it's uploaded, CHPD turns on, and this gets in here, and this starts messing with the serial link to your computer once again, but it doesn't really matter because you're not sending data from the computer anymore. You've got your code already uploaded. Neat trick, eh? CHPD enable, very important. You got to remember to turn that on at the beginning of the program. Okay, so that's up and running now. When it comes time to connect your phone to your ESP8266, you have to come into your phone and you have to come in and you have to search for your Wi-Fi networks. So go into your phone or your tablet and look for your connections, go into your Wi-Fi, and when you look around on there, you should see one that says Boombot or whatever you decided to call the network. And you go ahead and you connect to the Boombot network. Now, it will tell you that you won't have any internet access because, well, your robot's not connected to the internet, but you should get a connected without internet. You may get a warning saying, hey, do you really want to connect? You do. Okay, so then you come in here and you run your RemoteXY app, okay, and you probably won't see anything on that screen right now because what you'll have to do is you'll have to click the plus button in the top corner, okay, and you'll have to tell it that you want to connect to a Wi-Fi point, a Wi-Fi access point device, and you should be able to refresh that. And there we go. Mine pops up and I can see, oh, there's a whole bunch of networks around here, but right up at the top, I can see that I am connected to Boombot. Tap on Boombot and you'll connect on there and you should see whatever you created for a display come up right on there. And now you should be able to touch that button and it is blinking. You can't quite really see it because I adjusted the location so you can see the CHPD enable turn on and off. But there we go. It's blinking. Now, why have I spent all this time trying to get a bloomin' LED to blink on your board? We are going to do more complex things. We are going to make it drive around, just like you saw at the beginning of the video. But until you can make that LED blink, you can't make it drive around. Okay, so this lets us troubleshoot things with really simple, straightforward code. And if you're not getting through to your Arduino right now and you can't make this work, stop. Don't go on any further. There is a problem that needs to be resolved. Either something on your board is wrong, maybe you got an ESP8266 chip that's working at the wrong baud rate. Maybe you zapped maybe you zapped your ESP8266 with a static shock while you were carrying it home one day. Maybe you zapped your Arduino. Who knows? Maybe there's a scratch on your board. But if you can't make a single LED work, you can't make a more complex thing work. And it's really important to go through these complex things step by step. Okay, so if you've got that blinking, that is a great start. And we'll come back in a bit and we'll take a look at how to get it driving. Okay, well, there we go. We've got one LED working. Let's start driving. Okay, a couple of things that we're going to do on here. I'm going to drag this LED off to the side right here. Going to come down to the bottom here, and I am going to change that caption to fire. Okay, and maybe I'll make that button a bit bigger. There we go. Okay, and since we're going to use it as our Canon button, let's make that, oh, I don't know, let's play with the colors. Make that black text on a red background. Oh, no, undo that. Black background was fine right there. Oh, that's the one I wanted to change. Let's give us a nice red background right there for fire. I like that, right down in the bottom corner. Let's bring a joystick in right here. Okay, and I like to make the joystick a little bit bigger. Okay, and there's some properties for the joystick in here. You can play with the colors and all that. You've got joystick 1 in here. Now, if I drag down right here to the bottom, why is, oh, I have to click on the allow cookies button. Now I can see everything else down here at the bottom. So I'm going to click on the automatically center button. So when I take my thumb off, it comes back to center. And you can add an automatic centering button if you want, and that'll pop on the side. The G sensor button's kind of cool. You can add a G sensor button in there, and when you slide that button over onto that side, if you hold your thumb down on there, you can actually steer your robot just by tilting the robot or tilting your phone. So anyway, all sorts of different options that you can put in there. I'm just going to say no and no. We don't need that if I've got automatic center turning on and a nice big joystick on here. Let's see, so that's going to control my driving. And if you wanted, you could actually make tank drive. You could put 2 joysticks on there and slide your 2 different thumbs forwards and backwards. Cost you nothing. They're all virtual. And in here, we're also going to add an indication right in here. And let's put a graph. Okay, I haven't played with the graph before. I don't know if this is going to work or whatever. Let's put it on here. And let's variable name. I'm going to call that voltage. Okay, because we can monitor our motor voltage. So change that up, and I'm only going to put 1 variable in there. You could have multiple variables plotted in there, but why overwhelm things when we're just starting out here? Okay, so you can do all sorts of neat things with this, and this will enable us to send some data back up to your ESP8266. Okay, so we've got something that looks like that. I'm going to leave the color the same. You can change that up. It doesn't really matter. There's all sorts of things you can do. You can make a much more interesting, more complex interface. But for right now, I'm going to get the source code for this. And it's going to come out right in here. Okay, now I'm not going to copy all of the source code to begin with. Okay, I'm actually going to shrink the screen down a little bit and bring up my Arduino editor. And I've got my wired joystick drive. And so this is the code that I just created where I've got the joystick drive all up and running in here. And I'm going to take a look at how we can modify this code to get our wireless joystick drive going. So I'm going to save this. And let's see in here on my folder. This is going to be Boombot V2. I'm calling this 006C because it's the 6th project and the 3rd piece of software for it. And this is going to be wireless joystick drive. If I don't put the underscores in, Arduino will do that automatically. And I want to save it with a different file name so I don't write over top of my previous code and lose it all, because wired joystick drive is still useful. Okay, I'm going to shrink this screen down a little bit here so we can compare the two screens and add some things right in here. Okay, now in our const ints right up here at the beginning, I am going to add another pin in here, and this is going to be const int chpd enable. That pin that's going to turn um, our ESP8266 on and off is going to be right there, and we'll just comment in that pin 8 controls whether the ESP8266 is active. Actually, I should use the correct word, enabled. Okay, so high on CHPD pin is going to enable that. So now I'm just going to come down here and in my setup, actually I already had this in here. You may need to add this into your code right here. These two lines, we have to set CHPD enable to be an output, and then you have to do a digital write CHPD enable high. That will turn your ESP8266 on, and you should see that LED number 3 light up, and the LEDs on your ESP8266 come on and start communicating as well. Okay, now we have to start copying some of the code out of the screen. Fill up full screen, I didn't want that. Wireless joystick drive, there we go. So now I've got my Arduino code right here, and I've got my automatically generated code from the RemoteXY website right here. Here's some of the sections that we need to copy, okay? And so right in here, we're going to copy this section of code right in here. And we can put that anywhere up in the program before our void setup. Okay, so usually you want your hashtag includes to go up at the top. So I'm just going to put this right up at the very beginning before I do all the rest of the definitions and declarations. But right in here, I've just pasted that section right in there, and it works just like it did right in here. Okay. Now, I'm going to add this section. Actually, you know what I should do right now? After putting that section in there, I should verify. Okay, click on that verify button and make sure everything compiles okay. And you can't see the bottom of my screen. Let me just adjust this so that we can see the bottom of the screen on there. I've got two monitors running here. One of them is a 4K monitor, so when I drag it over to my high def monitor for recording, I sometimes lose the bottoms of some windows. Okay, and it gives me a redefinition of constant CHPD enable. I must have already had that in my code somewhere. Just make sure I've got it. Button pin, LED right, LED left. There we go. I put it up in here. Apparently I'd been playing around with this already. You shouldn't get that problem right there because this should all be fairly new to you. Okay, good stuff. Let's check that again. It's always a good idea to check and see if there is a problem. Done compiling. So I didn't cause any big problems by copying that in, and that confirms that I've got RemoteXY installed on my system. Like I said earlier, that's a library you need to add. So now we've added this section right here. Now we need to come in here, and this section where it defines what our interface is going to look like. You can see that's a little longer and more complex now that we've added some things. And in the structure variable right in here, okay, it's added an output variable here for online graph 1, and we need to come right down here, and you need to include all of this section right in here, and you can copy that straight out of there. And if you want, you can put that right here, right after you had all of the other RemoteXY information. So just Control V, that right into there, and you'll see that we've got button 2. Okay, button 2 is going to become our fire button. If I want, I can actually come in here and change that name into fire. I just have to use it as fire everywhere else in the system. Yours might say button 1. You can play around with that name right now if you want. Okay, so that's going to come back in here. It's going to be button 2, and we can use that. And here's our joystick, and it's got an X and a Y coordinate. Now you'll notice that the joystick X and Y coordinates are only from -100 to +100. Earlier when we were using our wired joystick drive, we went from 0 to 1023, which we converted to -512 to +512. So we'll take a look at how we map these out a little bit later on. Okay, we've got them installed in here. And now what we need to do is in our main routine right here, or in our setup, we need to do the remote XY init. So we copy that, and that's got to go into our setup routine. Okay, where is setup right in here? There's setup. Make sure you do it after your CHPD enable. So I'll actually do it after I blink the LEDs on and off right in here. Maybe as my last thing. Remote XY init right in there. Okay, and make sure that's within those squiggly brackets for your void setup routine. And then we need to keep running this remote XY handler each time our loop code goes around in here. So I'm just going to put this remote XY handler and do an auto format to make sure everything's nice and neat. And oh, I forgot to copy the semicolons. That would have created an error, which is why I always like to check these sorts of things. Okay, now, before when we were doing this, we were getting our joystick values by doing an analog read on the joystick X pin and subtracting 512. And then we were adding a deadband to it. The deadband, because it was an analog joystick. We can actually come down here and we can get rid of some of this section. We are still going to set a joy X, okay? But we don't need to worry about a deadband because this is going to be digital. And we're going to say joy X, and it gives us the value for joy X right up here, okay? It's going to be joystick 1X, okay? And that is going to be in the remote XY structure. So we're going to have to come down here and where we want to say, oh, did I go too far? Went way too far. Setup, loop, joy X right in here is going to equal remote XY dot joystick 1X. Okay, and we can do the same thing for our joystick Y down here. Okay, I'm getting rid of the deadband routine on here, and because I've got a large font, it keeps moving around on the screen. But joy Y is going to be equal to remote X Y dot joystick 1Y. That was pretty simple. Okay. You can leave your analog read button pins in here and all of this. And in fact, this should allow you to put some of the data out right here. Now your mapping is going to change a little bit down here, okay? Because you're going from -100 to +100, okay? And what you're now doing, I mean, it would work, just you can't drive that fast because it was originally expecting values from -512 up to +512. Now you've got -100 up to 100. So instead of dividing by 2, let's just multiply that by 2 for right now. It's still not going to get you quite up to full speed, but that's a factor of 4. That should enable you to get driving. We can leave all the rest of the code in here for printing our results out. And let's see if that works. And let's check that. Make sure it all compiles. And then let's upload that to our Boombot. And so again, this is all predicated upon the fact that you actually had an operating set of code. Oh, those serial prints in there are just going to mess us up royally because we can't serial print right now because we're using all of our serial data to communicate back and forth between the Arduino and the ESP8266. So let's come down here and in your void loop, find all of this serial print that we did for troubleshooting. And if it says serial.print, let's just get rid of it. There we go. That should clean things out right in there. And may as well come up here and get rid of our serial begin as well. We don't need that statement in there either because RemoteXY is handling all of our serial communications now. Let's upload that code and see if it works a little bit better. There we go. Okay, now I should be able to turn on my phone and come in here and run my RemoteXY app. Oh, and I lost my connection on there. So now my RemoteXY app should have seen Boombot before. I should be able to connect to Boombot. And yes, I want to connect. You may have to go back and manually connect to the network, but now you can see I've got a joystick and a button and that appearing on my screen. And if I turn my motors on right here, oh, that's my battery, there's my motors. Ooh. Ooh. I actually got it stuck on here somehow. There we go. Let me lift that up a bit more so that you can see. All right, on here I've got my joystick, and if I push, ooh, that's the wrong way. Okay, and I'm turning. I turn in the right direction, but it's a little bit slow in its response, okay? So we've got this moving around right now. Now we don't have the cannon firing just yet, and we don't have any data coming out right on here. Let's take a look at some of the things that are going on in here and see if we can figure out what's up, okay? All right, so we've got the RemoteXY handler coming in right here. And now we've got all these things that work. They work with the buttons right down here. If I push the buttons down here, they turn the headlights on. They fire the cannon. Okay, that's all good. But we need something else to add right in here. Let's get rid of that delay. I think that delay is probably what was messing up the handling. Okay, that was just there for the serial print statements. We'll get rid of all that. We'll add one more statement down here at the beginning, just like we had things right up in here. We can say if remote xy dot. Now I have to go up here and double check to make sure I've got the term right on mine. Let's come up here. It's called button 2. Yours might be called button 1 or whatever for the fire button. I should have changed the name on RemoteXY. If RemoteXY button underscore 2 equals to 1, then I want you to digital write motor 3, comma, high. And if that doesn't happen, just like we did above, else digital write motor 3, comma, low. There we go in there, and all of our brackets match up. If I do an auto format, everything's sort of indented correctly. And if I upload that to the computer now, I get an error. Oh, I was saying button 1. Mine says button 2. Yours might say button 1. If you get the name wrong, you'll get an error that looks something like that. It just didn't know what I was talking about. Okay, time to connect to RemoteXY again. Hit the Boombot button, finds the Wi-Fi access point. It connects me, and we have remote cannon control. Now, you might have to play around with your mixing commands for getting the robot to drive the way that you want, but I've just got to say, that's cool. Be even cooler if I had discs in there, but then I have to pick them up off the floor. Okay, let's take a look at the last thing we want to do. We want to take a look at our voltage, okay? And we've got this thing right on here. Where was our setup on here? Um, online graph underscore 1, okay? So what we're going to do is we're going to come down here, and just before we finish our loop routine, okay, so before that last one, after these commands in here, we can say remote xy dot online graph underscore 1 equals, now for right now, I'm just going to do read, and this is actually the analog read of A3. I should come back later on and tidy that up and say motor voltage is the name for that, but anyways, that's what it is. There's a voltage divider going in there. So I can say analog read A3. Okay, and that will take what it's reading on that pin and send it up to the computer, send it up to the screen so that we can see what's going on with our voltage. Now we can adapt that and we can modify it so we actually see a volt reading on there, and that can tell you if your motor battery is alive or dead. And I got an error on my screen right here because Boombot went to sleep when it got the code uploaded. That was that CHPD turning off automatically. Okay, and we've got connection right on there. We're driving, and let's see if I hold this right over here. You can see, oh, I'll hold it up here so that it comes in the right way up. You can see I've got a line at the top of the screen. That little red line on there is my voltage, and it's reading 593 right now. Okay, if I draw a current from there, you can see that it drops right down because that was when I was drawing current from there. So the internal resistance of the battery causes the motor voltage to drop. And in fact, if we zoom in on that quite a bit, I suspect what you'll see is that the range of voltage drop that it had on there probably coincided with each case where that cannon was had the elastic band all the way stretched out. It was when it was under its most heavy torque and it needed power to get it out. If I try driving the robot around, you'll also see, oh, I knocked something on the floor there, that my motor battery voltage fluctuates around right on there while I'm driving around. So you can monitor what's going on your robot and you can drive it around, all from the comfort of your phone. And you can create the interface that you want. So if you want live feedback on what the rangefinder is doing, what your edge detectors are doing, okay, or anything like that, how far your encoders have traveled, you can take all that data, display it on your screen on your phone. And if you want extra controls for lights, or you want to be able to control your NeoPixels on here. We haven't really talked about the NeoPixels all that much yet, but if you've got this working, you've got one of the more interesting things up and running. You can have it play different sounds from your DF Player Mini. So you've got a whole bunch of things that you can do once you get wireless control happening through your ESP8266 to your Arduino. Anyway, there you go. Yes, you do have to go figure out how to get your mapping all worked out so that your robot will drive the way you want. And yes, I do want you to go and add a few bit more bling and make your screen a bit fancier and have it display a few more things. Particularly as we move forward, we're going to use this as some of the code that we build upon to add more and more features here. So next time up, we're going to use this code as the base to maybe start getting some of your LEDs to start displaying some data in here. But in the meantime, all righty. Woo, got it all ready to go here. We got remote cannon control. I've got my XY axes all worked out, so I can turn left, I can turn right, I can move backwards, I can go forwards, I can drive slowly, I can drive fast. And I can monitor the voltage that's happening on my robot with the little graph off to the side, and you can see when I'm dragging that voltage down low. There's all sorts of other things that you can add on there. The only thing I'm embarrassed about is that I seem to have left all of my cannon ammo at home, so I can't run around the house blasting things.